Hey guys, welcome to the level 1 tables, equations and graphs paper from 2022. If you're joining us for the first time, the way this video works is that I go through each question, let you guys what you're going to need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question by yourself, and then unpause the video to see how you go about it, or how I go through the answers. Well, anyway, without further ado, let's get started. Alright, so with question 1, what we've got here is a straight line equation, and we need to figure out what the equation is. Now, if you do have a graphics calculator, you can put this straight into the graphics calculator with finding 2 points and kind of working through it. I am going to kind of go through this the long way for those people that are without the graphics calculator. So I'm going to pick a couple of points here. My first point is going to be this, which is 1, -4. And my second point I'm going to pick is this one here, which happens to be 2 and -1. 2, -1, 1, -4. Cool. Now, if you have the graphics calculator, just with these two little points, you would go into stat menu, put in the points. So you've got 2 and 1, you've got -1 and -4. Looks about right. We're going to go into graph 1, calc, and I think we're going to click on this X. And you've got the equation there, which is 3x minus 7. Alright, so if you do have a graphics calculator, that's you pretty much write down the answer there as y equals to 3x minus 7, and you would actually get an achieved for this. Now, if you don't have a calculator, what you need to do is you need to figure out what the gradient and the y-intercept is. Now, looking at this, the gradient, we know that the gradient is actually change in y divided by change in x. So basically what we've got here is it doesn't matter which order you go with. So if I actually use this as x1 and y1, then this point here would be x2 and y2. So it doesn't really matter which order you go in, as long as you keep those correct terms. So y2 in this case is -4 minus -1 divided by x2, which happens to be 1, and x1 happens to be 2. Okay, so what we've got here is -4 plus 1, which is -3, divided by -1, which equals to 3. Now, if m is equal to 3, we need to actually figure out y equals mx plus c. So we can actually put that here as y equals to mx plus c. We can use one of the points, so we're going to use 2, -1. And so that's going to be x, this is going to be y. So we're going to get -1 is equal to, remember that the m, which is the gradient, is equal to 3. So we've actually got 3 times x, which happens to be 2 plus c. So we've got -1 equals 6 plus c. Rearranging this, we're going to get c is equal to -1 minus 6. Or in other words, c is equal to -7. And so our equation is y is equal to 3x minus 7. And this is pretty much what we've got here with the graphics calculator as well. Now, if you do have the graphics calculator, as I mentioned before, you can write the answer only, and you straight away get an achieved for it. Okay, so let's go to the next part of this question. Right, so on to question 1b, part 1. We've got to actually find the equation of this particular table here. Now, before we actually kind of have a look at this table, now we know that we're going to get either linear, quadratic, or exponential, right? So what we want to do is we want to actually look at the difference between the L values, as in like how much increase is happening between them. Let me show you what I mean by. So between 8 and 15, we've got +7, and then we've got +9, +11, +13. Now, if those green numbers were the same, then we know that it's a linear equation. Now, if it's actually increasing by like a ratio, then we know that it's going to be an exponential. But looking at these numbers, it's kind of getting a gradual increase, and so we kind of know that this is going to be a quadratic equation. So the first step, as always, I'm going to show you guys how to do this in the graphics calculator, and then I'm going to try and show you guys how to do this without a graphics calculator. So what we can do is we're going to go into menu and go into stat mode here. Once we go into stat mode, we're going to put in about 5 of these values. So I've just taken those values from the table themselves, and I'll put in 108, 215, 324, 435, blah, blah, blah. Next, I'm going to click on graph, which is F1. Click on graph 1, and it's going to ask me to calc. And what I've got there is, I know that it's going to be a quadratic, so I'm going to go with x squared. And as you can see, the a value is given, the b is given, and the c is given. So the equation is going to be y is equal to 1x squared plus 4x plus 3. Now, of course, you don't want to be using y and x here, because if you think about it, you've got L and n. So we want to make sure that we actually put L 1n squared plus 4n plus 3. Now, here's the thing, guys. This particular question is it's actually worth a merit here, and it says it doesn't say anything about correctly filled in table or equivalent on diagram. Is there a diagram below? Okay, I'm not sure where they're talking. Okay, I guess you can kind of write the questions, and then correct formula is actually worth a merit. Now, it doesn't say anything about correct answer only or anything, because if I have a look at it here, they've filled in this rest of this parts, which I don't know why, but they kind of just left it empty, but I guess you could have filled it up. And then it does say that the equation is either this or this, allow in terms of x and y, which actually gives you a merit. So how do we do this question if we were to do this without a graphics calculator? Okay, so without a graphics calculator, the first thing to realize is that you're going to have y equals ax squared plus bx plus c. Now, we can actually figure out what the c value is, because if we were to go backwards in this table, and let's say if we have the number 0, we're not looking at the sides, but we're looking at just the numbers. So notice how between 1 and 2 it's plus 7. So between 0 and 1 it would have to be plus 5, which means the number before 8 would actually have to be 3. So what we've just figured out is ax squared plus bx, and that c value is when x equals to 0. So we've just figured out that it's 3. Now the second part to notice is that when we look at these numbers, all of these green numbers, they're going up by 2. And usually what that means is that the a value is whatever that second difference is, which is in this case is plus 2, divided by 2. So that means a is equal to 1. So we've got our equation, at least most of it, x squared plus bx plus 3. Now to figure out that b value, we just need to substitute a point. So we're going to substitute 1, 8. Doesn't matter which one you substitute. So I'm going to get 8 is equal to 1 times 1 squared plus b times 1 plus 3. So what I've got here is 8 equals 1 plus b plus 3, and we've got b plus 4 equals to 8, and then 8 take away 4 is equal to b. So that means b is equal to 4, which means we've got a little bit of working out here, but we still have the equation 1x squared plus 4x plus 3. So as you guys can see, it's fairly useful to have the graphics calculator, because it just saves a lot of time to get that merit question correct in about, I would say in about 1 minute, less than a minute, compared to the amount of working you need to do here. Okay, we move to the next question. Right, I can see why we needed a table, because it actually says, using the axis below, draw the graph to show the pattern in B1, show the results as far as n equals to 8. So we're going to go back to the table, and we're going to kind of add up some of these values. So we should have plus 15, which means we're going to have 48 plus 15, which is 63, and then we'll have plus 17 plus 19, which means we've got 80, and we've got 99. So basically we've got to take this table and we've got to actually draw it on that graph. Now I've got to remember these numbers: 8, 15, 24, 35. Okay, let's try this out. So at 1 it's going to be 8, 15, 12, 14, 15 is going to be somewhere the halfway point there. We got 24, 35, 48. Let me see if I can remember that. 24, 35, that's 34, so 35. Nope, forgot the numbers. 48, 63. We got 80, and then we should have 99. All right, now as for this graph, guys, we don't actually join this, even though it's a quadratic, and your first instinct is like, oh, I should really join this to create one of those shapes there, right? Like one of the parabolic curves. We shouldn't really, because think about it. This one, you're actually dealing with side numbers, which means you're actually dealing with whole numbers here, right? So you're not actually dealing with, like, you don't have like a 3.5 side or a 3.6 side. So really important that you don't actually join the curve at all in this. And if you guys have a look at the answer schedule, they actually say graph drawn with discrete positive values only. And then if you can do that, you're looking at a merit for this particular question. No negative values plotted. That's really important. And of course, they don't really worrying about the 0, 3, or 0, 0. So I would just plot the points that I actually have on that table. And if you're able to do that, that is a very easy merit question there. All right, let's go to the next one. All right, guys. So with this question, what we've got here is a couple of, what do you call it? Up to 6 kgs. Okay, so if a parcel weighs less than 6 kgs, then the cost of delivery will be $8. So what we've got here is, so we're going to write it up like this, right? Let's say the x is, well, x-axis is already weight of the parcel, and y is the cost of delivery, right? So when x is between 0 and 6, but it's got to be less than 6, we know that the cost of delivery is $8. So we can say that y is equal to $8. So we're going to actually draw that first between 0 to 6. And what we're going to do is we're probably going to put, and I guess this is always a question that people ask, you know, it's like, when do I put this filled dot and an empty circle? So in this case, it's $8 starting from 0 to 6. But I'm just going to put that little, you can kind of see it, it's a little open hole there, just to say that it's actually less than 6, that it's going to be $8. So that's the first line there. The second one it says is when it weighs more than 6 kgs, then the charge will be $1.50 per kg. So when it's between 6 kgs and up to a weight of 25 kgs. So that's going to be between 6 to 25. The cost is going to be $1.50 per kg, so $1.50 x plus an extra fixed $1. Right, so $1.50 x plus $1. So we're going to write this as 1.5x plus 1. And now we need to actually draw this up, right? And here is where things can get a little tricky. So oh no, it wouldn't, because it's $1.50 and it's 6 kgs. So let's actually go to the calculator, and what we're going to do is we're going to work out what's the price, because remember, if you want to draw a straight line, you only need really 2 points, right? So what I'm going to do is I'm going to go in here and I'm going to go $1.50 times, what is it, 6 kgs and plus $1, because $1.50 times 6 plus 1, yeah, that's $10 right there. So when it's 6 kgs, it's actually going to cost $10, which means it is a closed point. And then I want to go up to a maximum of 25, so I'm going to go 1.5 times 25 plus 1. And that's giving me $38.50. So if I go to $38.50, that's 39, roughly there. All right, this one is going to be quite awkward because I can never get a straight line with these things, but I'm going to try. Not bad at all. So that is my line for the second part of the question, when it actually weighs 6 kgs or more. So notice how both of these points here, they're actually closed points, and then this one is open point because it's less than 6 kgs. All right, that's something that you guys need to remember. Now, when I look at the answer schedule, we've got one of these kind of like double T combined questions. Now, correctly drawn graph of 1 point flow, correct graph for both sections of the graph for parcels to correct correctly. Okay, so if you draw both of these graphs correctly, you are looking at a merit. If you draw one of these graphs correctly, then you're looking at an achieved. Okay, that is just something to keep in mind. All right, let's go to the second part of this question. Right, so for this next delivery company, they're charging $2 per kg for values of parcels up to weight of 15 kgs. So that means from 0 to 15 kgs, up to a weight of 15 kg, which means it's going to be up to a weight of 16 kgs, they are charging 2x because it's 2 times per kg. However, if it's 15 and all the way up to 25, they actually have a flat fee of $34, which means a flat line, that's just going to be 34 like that. So what they're saying is compare the cost of delivering parcels. You should provide evidence of all equations, domains, and graphs, blah, blah, blah. So we're going to go back to our grid here, and we're going to need to put this next graph on here. So between 0 to 15 is 2x. So that means at 15, we're going to be charging at $30. But of course, that's going to be a open hole. And once again, I'm going to have to try and draw a straight line here, but something like, come on, there. It's close enough. I think you guys get the idea. So between 0 to 15, that's 2x. Then what they say is between 15 to 25, it's $34. So 15 to 25 is $34. That is from here to here. Yes, I shall actually use a ruler for this. So these are my 2 lines there. I'm just trying to see. Now what it says is that compare the cost of delivering parcels, blah, blah, blah. You should provide evidence of all equations. Right. So I guess what you kind of need to do in this situation is we're trying to figure out what's the optimal company to go with, right? So there's a couple of things that we need to know. The first thing we're going to need to know is we need to figure out what this point here is. And we also going to need to figure out what this point here is. So there's 2 points that we need to work out first. So let's actually work it out. So the first one I'm going to work out is this point here. I know that I've got y is equal to 8 and y is equal to 2x. So when I put that, 2x is equal to 8, I'm going to get x is equal to 4. So it's kind of pretty obvious there because we can kind of see it here. That's going to be 4. Now the next point is this point here. We know that y is equal to 34. And the other equation is y is equal to 1.5x plus 1. So we're going to put 34 equals 1.5x plus 1. Rearrange it. We're going to get 34 minus 1 equals 1.5x. So we've got 33 equals 1.5x, and x is equal to 33 divided by 1.5. Of course, I can't remember this. 33 divided by 1.5, that's going to give us 22. And once again, we can kind of see that if you track it all the way down there, we can see that it's actually 22. Now, you could read it from the graph, but I'd always say do the calculations just to be absolutely sure. Okay, so what we're going to do is, if we look at which one is the cheapest, right? I'm going to actually look at the cheapest option for me, depending on the weights that I'm going to send. If I'm going to send between 0 and 4, I probably should go with Hohoro. After 4 kgs, I probably should go with whatever that other company, Parcel to You is, all the way up to 22 kgs. Because after 22 kgs, I'm probably going to go back to Hohoro. So, best option, so you can kind of mention that basically cheapest depending on weight. So between 0 to 4, you probably want to go with Hohoro. Between 4 to 22, you want to go with Parcels to You. And then between 22 to 25, you want to go back with Hohoro. So this is pretty much one of the things that you can actually give. So you've given the domain, the equations, I've provided all equations, domains, and graphs. And we've also drawn the graph, and we've also given the suggestion of what should be the cheapest. All right, so let's have a look at the answer schedule here, because there's quite a few to unpack with the answer schedule. So first thing, all sections for both graphs done correctly. Yeah, we did that. Equations for at least 2 of the 4 sections. We've done that. Identifies correctly even blah, 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 blah. Correct. When Hohoro and Parcels is done that. We've all done that as well. For T2, all sections drawn correctly. Closed and empty symbolization. So that's that closed and empty stuff that we were talking about. And all equations, blah, blah, blah. We did all of that as well. Correct domains, we did that as well. And valid interpretation, again, we did all of that. So there's lots and lots of opportunities here to get merit or achieved, guys. And it's almost like there's just too many things happening here in terms of what you can do for achieved and merit. All right, but in terms of excellence, keep in mind that when you're working with straight lines and like particularly working with like less than or less than equal to, you've got to have that fill closed hole and open hole. That's just something you need to remember. All right, anytime you're working with less than or greater than, like I've highlighted in the green there, you're looking at a open hole. And anytime you actually have the part that I've highlighted in with the blue, that's always going to be a closed hole there. Cool, guys, that is an excellence question, but it is by the looks of it, it looks like it's a E8, so it's a T2 question. There's 8 points worth in there, but that's pretty much it for question 1, and we will go to question 2 next. Alright guys, so question 2A1, what we're going to do is, as usual, I'm going to show you guys a couple of ways of doing this. So first up, we've got 4-8. I'm just going to take some points here. We've got 7-1 and we've got 1-1. Yeah, it's somebody sitting. I know he's it's all right. Let's just keep going. 1-1, 7-1, 4-8. Okay, so I'm going to go into the calculator and I'm going to go into stat mode. Let's just get rid of all of this. So can I just delete all of it? No, can I? Yes. Delete all. Yes. Most old calculator you can ever think of. But anyway, what do we got? We've got 147, and then we've got I've got -8 there. Oops, sorry. 1 minus 8 1. So we're gonna go into graph 1, calc x squared, and there is our equation. Our equation is y is equal to x squared minus 8x plus 8. Cool, so that gives you an achieved grade. Now if you don't have a graphics calculator and you've got to do this, you can actually use the vertex form, h minus x squared plus v. I think this is one of the formulas that I use. You know, you can actually use any other formulas that you kind of remembered as well. So I'll take the vertex here, which is 4, -8. So this is the vertex right here, 4, -8. So then I've got x minus 4h squared plus v, so it's minus 8. I got to figure out what the a value is, so I need to use a point. I'm going to use the point 1, 1. So I've got 1 equals a times 1 minus 4 squared minus 8. I've got 1 equals a times negative 3 squared minus 8. Rearranging it, I've got 1 plus 8 equals a, negative 3 squared is 9. I've got 9 equals a times 9. So a is equal to 9 divided by 9. A is equal to 1. So if you don't have a graphics calculator, then this could be your answer here, which is x minus 4 squared minus 8. Once again, it is what achieved, and we pretty much go on to the next part of this question. Now the next part of the question, it actually says, describe in words how the position blah 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 4x plus 8 squared 16 compares to the graph above. And I guess this is where having this in vertex form really helps, because it's actually a lot easier to work from vertex form compared to the graphics calculator form. So with the vertex form, I'm just going to write it below here. This was the original equation. And so we can actually talk about a few things here when you have it in vertex form. The first thing we're going to look at is the vertical shift. It's actually gone from minus 8 to 16. So we can actually write a sentence that something like new graph has vertical shift of 24 units. Then we can have a look at the horizontal shift, because that's plus 8 and minus 4. So we could actually say new graph has horizontal shift I forgot that vertical shift of 24 units upwards, we need to say. And in this case, horizontal shift of 12 units to the left. Because if it was going to the right, then it'll become even more negative. So, but in this case, it's actually plus 8, which means it's actually shifted to the left 12 units. You could also say the new vertex. New vertex is negative 8, 16. And that's of course figured out from the negative 8 is obviously the opposite of that, and then the 16 comes from there. So we've got 3 things there. The other thing that we also can talk about is, I'm running out of colors here. No, the 4 there. So we can actually say the new graph's width is skinnier. I don't know, what else would you call it? And of course, I looked at the answer schedule. They've got one more statement, which I don't think, if you really think about it, it's only asked for 2 supporting statements here, and we've given about 4 in here. The last statement that the answer schedule had was that the new graph will be totally about the x-axis. Now, yeah, that's like almost like a fifth annoying one. So you need 2 of them to get a merit, and you can get an achieved with 1 correct supporting statement there. All right, so let's go to the next question here. Cool, so what we've got here is blah blah blah. We've got a parabolic equation, which is write down the value for q. Now here's the thing, right? This parabola is minus px squared plus q. Now that q is the c value. Remember, it's the constant when it's by itself. And if you look at the graph here, you've got a constant there, which is where the graph is actually cutting the y-axis. So here we can straight away say that q is equal to 9. Correct answer. Only this question is actually worth an achieved. Now the next part of the question says, if the ball lands 4 meters away from the base, what's the value of p? So we've actually got this. we've actually got, it lands 4 meters away from the base of the house. So that means when x equals to 4, the height is equal to 0. And we've got the equation, h is equal to minus px squared plus q. We figured out what q is because q was 9. And we also know what h and x is because h is equal to 0, x is equal to 4. We substitute it in. So we've got 0 is equal to minus p times 4 squared plus 9. And rearranging this, we are going to get expanded first. 4 squared is 16. So we got negative 16p plus 9. Take the 9 to the other side, it becomes minus 9. 0 minus 9 is just 0. Negative 16p. And then p is equal to negative 9 divided by negative 16. Or in other words, we can say that p is equal to 9 over 16. You can write it as a decimal if you want to, but you could also leave it as a fraction. This question is worth an achieved. All right, part 3 of this question. Let's have a look here. Alright guys, so with this question, what we're going to do is I'm going to show you guys first how to do it in a graphics calculator, and then kind of show the manual way as well. Alright, so the first thing is recognizing that this point right here is actually 0, 9. Now, it says the maximum is reached 0.5, which means we theoretically have a line of symmetry through that 0.5, which means if that's 0.5, this point here is going to be 1, 9, and of course our final point is 6, 0. So there's our 3 points there. We could now go and substitute it in our calculator. Of course, I'm not typing on the calculator, that would help. 0, 1, and 6. What we've got here is 9, 9, and 0. So let's actually put this graph, and we're going to go graph 1, calc, and we're going to get x squared. There is my equation for this graph, which is y is equal to negative 0.3x squared plus 0.3x plus 9. Now, if I want to figure out what the maximum height is, I could just draw this, and let me just see if I can actually work it out here. Menu, go into graph, and let's see if this, no, it's not there. Go back to stat. Graph 1, calc, x squared, copy into y1. Let me see if this actually works. Yeah, there we go. Draw, of course not, it's not going to work. Where's the mistake? Let's just type it again. Okay, so we got negative 0.3 multiplied by x squared plus 0.3 multiplied by x plus 9. Okay, so there's the graph, and I can click on Gsolve and I look at the maximum right there, and it's going to give me a maximum of 0 is x 0.5 and y is 9.075. So this is all from the calculator. Alright, so I've figured out what the maximum height is, which is 9.075. Now, if you do only use a graphics calculator for this, correct answer only, I'm looking at the answer schedule, hang on, let's have a look. So correct answer only is going to get you an achieved consistent evaluation of the maximum height. So I'm guessing you can actually do this to get a merit. Showing that equation is that or equivalent and maximum. Oh, okay, so there we go. So you might have to show that equation to get that T1, which is an excellence grade. But anyway, let's go back to it, and I'll show you guys how to do this the manual way as well. Okay, so with the manual way, what I'm going to do is I'm going to just draw a very quick, ugly looking sketch here. So there is 6, there is 0.5, and there is 0.9. Now, according to parabolas, we know that parabolas are actually symmetrical. Now, if they are symmetrical, this graph just kind of keeps carrying on, and we need to figure out what this value is. Now, from here to here, it is 5.5. So from here to here should be 5.5. And because 0.5 is already taken up here. This distance from here to here must be 5. So what we've got here is that point there is going to be -5. So we can actually write this equation as y is equal to k, because we don't know what that the a value is. I mean, you could actually put it as a if you want. It doesn't really matter. We've got x minus 6 and x plus 5. So this is our equation that we're going to work with. Now we need to figure out what that a value is. But what we do have is we have a point, which is 0, 9. And we're going to substitute it in. So we're going to get 0 minus 6 and 0 plus 5. So 9 is equal to a times -6 and positive 5. 9 equals a times -30. And what we're going to get is a is equal to 9 divided by -30. All right, now 9 divided by -30, we can put that in the calculator. Let's see, 1. So 9 divided by -30 is -0.3. So our a value is -0.3, which is what we've got here. Cool. Now that we have the equation, our equation is equal to y is equal to -0.3 x minus 6 x plus 5. So we've got the equation, and now we need to figure out what the maximum height is. Now the maximum height happens when x is equal to 0.5. So y is equal to -0.3, 0.5 minus 6, 0.5 plus 5, and we're going to get -0.3, -5.5, and positive 5.5. So we're going to get times -5.5 times 5.5, and that gives us 9.075. So we can kind of say that max height is equal to 9.075 meters. By the way, guys, that is also worth a T1 if you were to show the full working, because that's what it means. You're showing that equation and equivalent and the maximum height found. But if you just did that equation from a calculator and just kind of put the thing, you probably can get up to a merit. But if you can do the showing the working, you are looking at a possible T1, which is actually excellence grade. So hopefully that kind of explained it. I don't need to go back and individually kind of mark these things. So hang on, let's just do that anyway, just for the hell of it. So merit for the equation and the point. Excellence if you were to do all the working there. All right, let's go to the next question. All right, guys, so with this question, there is, wow, so you're just solving the equation. That's basically it. We've already got the equation, right? Our equation is y is equal to, what was it from before? A was -0.3. Oh yeah, now I remember. So this was our equation, -0.3 x minus 6 and x plus 5. Now what you need to do is you actually need to figure out y is equal to 3. What is x? Right, now the good thing is, if you have a graphics calculator, you can literally read off the answer, because all you just go is menu into graph. You've already had that graph, and what you can do is you can actually go gsolve, and where is it? Is it xcal? Yeah, I think it's xcal. Enter y value. Y value is 3, and there you go. We get an answer of x equals to 5. So straight away you could actually write down that x equals to 5, but the problem is, if you write just the answer only, you are looking at an achieved. All right, so what you want to do is you want to actually show the working. Now to show the working, what you could do is you go y is equal to 3, so 3 is equal to -0.3. We've got x minus 6, x plus 5. Now here's where some of your algebra is going to come in handy. Get rid of that -0.3 first, which is going to get divided by, and you've got x minus 6, x plus 5. Now 3 divided by -0.3 is -10. We've got a quadratic here, we are going to expand it. When we expand it, we're going to get x squared minus 6x plus 5x minus 30. And if I was to carry on, I'm going to get 0 is equal to x squared minus x minus 30 plus 10. And I've got 0 is equal to x squared minus x minus 20. I can factorize this now as x minus 5 and x plus 4. And if you remember from your algebra, you've got x minus 5 is equal to 0. So x equals to positive 5, or x plus 4 equals to 0, and x equals to negative 4. Now, the reason you're getting a negative 4 is because remember, the parabola it looks like this, and at some point, the height there is going to be 3 as well, and that's where that negative 4 is coming from, and the 5 is actually coming from there. So we're going to write a little statement that Danny is 5 meters away from the apartment. And doing this, guys, you are actually getting an excellence with T2, which means you're actually getting an E8 for it. All right, and that statement is necessary. Always remember that these excellence questions, these big excellence questions, you always got to write some sort of statement just to get that final mark there. We're going to ignore the negative 4 because you can kind of see that's actually going inside the building, and we don't really care about it, so we're only caring about the positive value. All right, guys, that is it for question 2. We now go to question 3. All right, guys, so with question 3A1, what we've got here is an exponential curve, and it's the first question. Usually these types of questions, they are quite straightforward and simple, so they're not going to be like overly complicated, right? So what we want to do is we want to try and pick up a couple of things here. The first thing to notice is the asymptote here is at positive 2. So whatever this graph is, it's straight away, we can kind of say it's the whole thing is actually increased by 2. All right, that's pretty much what that 2 means, right? Because normally if you have like an exponential curve, the asymptote will be along the 0 there, but in this case it's not there. So it's actually moved up by 2. So we're going to put that plus 2. The next thing is to try and figure out what the ratio is. So at 1, it's at 5. At 2, it's at 11, is it? Yep. And at 3, whoa, it's going way back. What are we on? 3, what am I looking at here? Is it 29? And at 3 at 29, all right? So I'm going to put this out in a table. So 1, 5, 2, 11, 3, and 29. Now remember at the start of this video that I said that you always have to look at that second difference and see if there's a pattern happening, right? Now in this particular one, you can see that this is going plus 6 and this is going plus 18. And if you look at the difference, it's actually getting tripled. And if you don't believe it, have a look at 0 as well. Like when it's at 0, it is at 3. And if you look at it, 3 to 5 is actually plus 2, and 2 times 3 is equal to 6, and then 6 times 3 is equal to 8. Now that 3 right there is what the ratio is. So it's actually getting increased by a rate of 3. So in other words, we could actually say this simply as y is equal to 3x plus 2. All right, now there is another way I've actually done this, which is a little bit longer. And if you are interested in it, just search up how to find exponential equation given 3 points. And there is another way that you can do this as well. It's a little bit longer, but it's just, I don't want to keep doing that same method again. I'm just trying to show people different methods you could potentially work with. Okay, so let's have a look at the next part of the question. The next part of the question says shifted 5 units up and reflected on the y-axis. So we are going to get y is equal to 3x plus 2. Now what I'm going to show you guys is let me see if I can actually show you guys this on Desmos. I know you guys don't have Desmos in your exams, but the thing is, it does kind of help understand real quickly on what to do here. 3 to the power of x plus 2. Okay, let me just go in here. So we want to shift this up by 5. So if we want to shift it up by 5, we just add a plus 5 to the top there. Okay, hang on. I want to actually put the original equation. This is my original equation, and then here is my second equation, and it's been moved up by 5. So that's that first part, 3x plus 2 plus 5. So that vertical shift, when it's actually shifted up by 5, we can write this as 3 to the power of x plus 7. But one other thing is, it's been asked to reflect it in the y-axis. So if you look at it, this is the y-axis, and we want to reflect it on the y-axis. And here's a little tip for you guys. If you want to reflect it on the y-axis, all you got to do is you got to go find every x and put a negative in front of it. And in this case, we've got this 1x, and so we're going to put a negative in front of it. So if we go back to our original question there, what would the new equation be? We're just going to put this little negative x right there. And by doing that, correct equation. Well, it's really interesting because, like, I'm looking at the answer schedule. This is an excellence question, because they're saying correct equation before and after both of the transformations. What do you mean by that? After both of the transformations. Oh, well. See, I just thought you could just write the full answer, because it just says shifted 5 units up. I guess you could actually do it like that if you want to, but I would have just done the final answer, because 5 units up equals 3x plus 7. Reflected y-axis, I'd probably put it as y equals negative 3 to the power of negative x plus 7. Or equivalent. Yeah, I would have just given them y equals 3 to the power of negative x plus 7 as full excellence. I wouldn't need to have like that both transformations there, but well, that is an excellence question. There you go. Sorry, by the way, the previous question was worth and achieved. Forgot to mention that. Anyway, let's go to question B, part 1. Okay, so what we can say with this is blah, blah, blah. Well, the temperature doesn't actually... Well, the coffee is not going to drop below that... How do I put it? I mean, if you really think about it, right? I mean, it becomes, at 0 degrees, it becomes ice cold. Well, it freezes at ice, but then I don't know what temperature coffee freezes at. But anyway, the idea behind in this is... because the asymptote is at 20 degrees, we can actually say room temperature is equal to 20 degrees. Nothing more to it. And yeah, but I guess you do need some justification, they're saying. So I guess we can kind of say because asymptote is at 20 degrees. So you might just need to say that little statement as to why that it's there. So it's an achieved question. All right, part B. Well, not really part B, but part 2. What do you got? After the first minute, the temperature drops to 60. Find the value of K. So this is just a substitution question, guys, because what we have got here is when T is equal to 1, H is equal to 60. So we've got 60 equals 50, K to the power of 1 plus 20. All right, and it's just a simple little rearranging question. So we've got 60, take away 20, equals 50. K to the power of 1 is just K. So we've got 40 is equal to 50K. And then K is equal to 40 divided by 50. which gives us a k value of 0.8. Now this question is worth achieved, and they're saying it's got to have some justification. I'm assuming that the algebraic working is the justification, so we're gonna move on from that question now. Part 3 of this question. Alright guys, so with this question, the first thing that we need to do is we need to come up with the equation for this t, right? Now, so a couple of things to notice is, the first thing is that temperature at the start was 92 degrees. So when t is equal to 0, we know that the temperature is equal to 92. Now it also says that the room temperature was 16 degrees, so that means the asymptote is equal to 16 degrees. So we can kind of see that this little v here is going to be the asymptote, which is 16 degrees. So let's actually work that out first. We've got h is equal to w times 0.85 t plus 16. We know that 0, when it's 0, it's 92 degrees. So 92 equals w times 0.85 to the power of 0 plus 16. So 92, take away 16 first. We do that. Is equal to w times 0.85 to the power of 0 is 1. So remember, any number to the power of 0 is 1. So we've got that, and then we've got 76 is equal to w. So the equation that we have is h is equal to 76 0.85 t plus 16. Now guys, this question here, it actually says that use tables, graphs, or equation, find how long it took for Tim's mother to blah blah blah, justify your answer with full and clear working. Now you may choose to use the graph paper on the next page. Now here's the thing, I'm gonna go back and get Tim's equation. What was Tim's equation? 50.8 t plus 20. So 50.8 t plus 20. This is the, was it a cup of coffee did he have? Yeah, so he had a cup of coffee, so we're gonna put a little c. This was the t. Now the first thing I'm going to show you guys is this. Remember, in this particular question they've actually said you could use tables, graphs, or equations. So unfortunately you're gonna need a graphics calculator for this to get a really easy table. So let me show you guys how we can actually get that table first. Now looking at the table, we want to go for a certain period of time, right? So the best way to do this is actually to go into graph mode and actually draw the graph. So I'm going to get rid of this graph first, and I'm going to put in the coffee one. So it's 50 times 0.8 to the power of x plus 20. Then I've got 76 times 0.85 to the power of x plus 16. I'm going to draw both of these graphs. Now obviously I can't actually see this graph here because of my window, the view window. So I'm going to go in here, I'm going to put down my y max as probably 100. And then as for the x scale, I might just put a max of, I don't know, let's go 25 maybe. What did the graph show? Let's go look at the graph. The graph actually showed up to 30 and 100. So let's go 30. Let's go 31. So as you guys can see, there is the two graphs. Now you can actually just kind of copy this graph from here into this little grid here, which, sorry guys, I'm just not going to do this at the moment. But what you can do though, you can actually click on Gsolve and look for the intersection point. And when you click on it, there is the intersection point. So in other words, after, what is it? Which one is at the top? Now if I was to, I'm going to draw a rough, forget it. Let's just do it. Do this. So I'm going to do that one first. And h of t, and then that is the coffee. So the t starts at 92. and the coffee starts at 70, which is going to be somewhere here. And at 16.4, according to my graph, 16.4, 20.2. God, that's going to be such a painful thing to draw. That's 16.4, so roughly somewhere here. No, that's 15. 16.4, it's at 21.2 degrees. Yeah, somewhere there. That's where the graphs actually meet. So, in other words, I'm gonna do this as a rough sketch, but I'm hoping that you guys can kind of get the idea of this later. But this one is actually up to 16, right? So, oh man, where's 16? 20, 19, 18, 17, 16. Okay, so that's not supposed to go. That is not going past 16. Something like that. And the green one shouldn't go past 20. Something like that. That is my really ugly looking, terrible looking graphs there. But what I do know is the point, this point right here is 16.4 and about 21.2 degrees. So it kind of sucks because like you guys can't do this algebraically at the moment, because algebraically you actually need to use logs, which comes at level 2, but you can actually kind of show the equation equal to each other and can get to a particular point, but even then you'd still need to use like solver or something like that to show what it is. So what do we do then? Let's see if we can get a table, right? If we want to get a table, what you can do is go into your graph and click on this table function. Okay, and because you've already entered those two graphs, you can actually create a table straight away. But what I would do is click on set, and right now it says start is 1. I'm going to put start as 0 and end as how far do we need to go? 2, 4. Yeah, it's just like, I mean, you could put it to like roughly 20 just to get an idea. Step 1. And if we click on table, oh no, this has done this thing again. I must have made a mistake somewhere. Let's try this. F1, table, condition error. No, this is not going to work. I guess then you'd have to do this manually, guys. So what you need to do is you need to create a table and just go T and then H of tea and then H of coffee, and you literally start putting some numbers in there. So you'd have to put like 2, 4, 6, find out these values, and then eventually try and get close to that 16.4 as much as possible. So it's a bit of an odd question to finish off, but I want to show you guys the answer schedule just to show you guys what it shows. So T graph drawn, which we kind of did, T equation, which we solved, tables of values produced, conclusion from graphs and tables, which we said that approximately same temperature after 16.4 minutes, which we did that, and T will be cooler after this time. So we just need to write a statement. But the way in which you can do for the actual marks, so you got to have a graph drawn or a table. Now we did a graph. We got a point of intersection from, no, we didn't get 15 to 18, which we did, but we need to interpret it, which the interpretation is like at 16.4 minutes, the two temperatures are the same. Use table equations or graph for both drinks, which we did. We did a graph for this, except from 16 to 17, and clearly interpret it. So in some ways, we kind of did the answer, but I would say if you guys have the time, you actually create a table and kind of show the values as well. Otherwise, you might just be, would I give this as, this is a rough graph, right? But what I have done though is I know that at 16, which is somewhere here, is an asymptote. So it's kind of following that asymptote of 16. All right, and then of course the other graph has an asymptote at 20. It's a rough graph. It's not accurate. And I guess the question I'm asking myself is, would I give excellence for this? Yeah, I'd probably get the table, get some rough points in there to get that excellence grade, guys. So yeah, going back to that answer, have a look at the answer schedule just to see what are all the different ways in which you can potentially get those grades from. But apart from that, I think, yeah, see, they've given a table, they've given a graph, but of course they've got this graph from Desmos, so that's nice and easy. But for us, we've got it on the graphics calculator and it's a little bit more trickier. Anyway, cool guys, I think that's pretty much it for question 3 there. I mean, it was a lot shorter than I thought, but it did have a nice theme of like question 1 was linear, question 2 was quadratic, and question 3 was exponential, which it's pretty interesting to see. Anyway guys, that's basically it for this video. What was I going to say? With these exams, like, you know, having the graphics calculator does help, and I know it can be a bit of a pain because it costs quite a bit, but it does make life a little bit easier for this type of exam. You know, my suggestion is like, learn how to use the graphics calculator, see if you can borrow it from other people, you know, just to be mindful of like what's happening with the next 2 years. We're not really sure what's happening with fully, but I think with the level 2s it should still carry on. So yeah, just get into the habit of like using that graphics calculator. Borrow it from a friend if you can, or like go on TradeMe, you might find it cheap. It's definitely useful. Don't be that person that buys the calculator the night before the exam and then kind of go into panic mode that, oh, I don't actually know how to use this. There is a graphics calculator playlist as well. Somebody needs to remind me. I'll put it in the link somewhere. But apart from that, yeah, there should be some messages popping up. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.